My dear students, in my previous video, I have solved some problems under the topic differential equations. We have solved some differential equation problems under the method Variables Separable. The separation of variables are introduced in the previous method. So solving of differential equations are applicable by the Variables Separable method. We have solved using Variables Separable method, we have solved some problems. In this video also, I am going to continue the same type of problems using Variables Separable type. That is, the problem is, it is given in the exercise 10.5 in the State Board 12th standard textbook. See, this differential equation topic is also given in CBSE syllabus also. So, in both 12th standard, both in the CBSE and State Board syllabus, the topic differential equation is there. The exercise number may be different, but problems are same, both in the CBSE and State Board stream. So, both the students can follow these videos and thereby you can easily solve the problems in your examination. So, consider the problem solved. These problems are solved using method of Variables Separable. That is dy by dx equal to e power x plus y plus x cube into e power y. This is the problem. Dy by dx equal to e power x plus y plus x cube into e power y. You have to separate the variables, x variables and y variables. This is, you consider this is e power x into e power y. This is e power x into e power y. E power x plus y I can split into e power x into e power y because e power x plus y. This is e power x plus y into x cube into e power y. You can split this by exponential rule. E power x plus y is e power x into e power y. So from this I can take e power y as a common term. I will get e power x plus x cube. Now you bring this e power y to the left hand side. It has become 1 by e power y. And already dy is in the left hand side. Here e power x plus x cube into dx. This dx you bring to the right hand side. So now the variables are separated. Now we have to integrate both sides. That is e power 1 by e power y I can write as e power minus y dy. 1 by e power y I can express as e power minus y dy. And this is e power x dx plus integral x cube dx. You split this into two integrals. So e power minus y is minus e power minus y. Integral of e power minus y is minus e power minus y. Because power of the exponential power, if you get minus, you will get minus term in the answer after integration. And here e power x, integration of e power x is e power x plus integral x cube is x power 4 by 4 by integration rule plus c. Okay. Now you bring this e power y also to that side, minus e power y. Already you get e power x in the left hand side. If you bring this minus term, you will get plus e power minus y. If you bring this to the right hand side, the minus e power minus y becomes plus e power minus y. And already you have x power 4 by 4 equal to this plus c. If you bring it to the left hand, it is minus c. You call it as by another constant capital C. So e power x plus e power minus y plus x power 4 by 4 plus c. If you bring it here minus c, that minus c is nothing but another constant. So otherwise you consider this is c1. If you bring it to the right hand side, it becomes a constant c. That's all. This is the answer for the problem. So, see, the variables should be separated. Y dy and x dx variables are separated, and then we have to integrate. Then we get the general solution. This is the general solution of this problem. Next one. This is problem number 1 in this video. This problem is given in both State Board stream and CBSE stream also. Some functions may be different, but the method is same. Next, second problem. Second problem. Solve e power y plus 1, e power y plus 1, e power y plus 1 into cos x dx, into cos x dx, plus e power y into sin y dy, plus e power y into sin y dy equal to 0. You see, sin y dy cos x dx. So, e power y plus 1 into cos x dx is equal to, you take it, the full term e power y minus into sin y dy to the right hand side, it becomes minus e power y sin y dy. Okay. Again, this is cos x dx equal to, you bring this e power y plus 1 to the right hand side, it comes to the denominator, that is 1 by e power y plus 1 minus of e power y sin y dy. Okay. So this is equal to minus e power y by e power y plus 1 sin y dy. Here you get cos x dx. One plus, okay, e power y into cos x. One minute. Yes. Or the problem is wrongly expressed here. This is sin x dx. E power y, this is not sin y, it is sin x. So that's the doubt I got. Listen. See, in the problem it is given as e power y plus 1 into cos x dx plus e power y into sin x dy. This is the problem. Now, you correct it, this is sin x dy. Now, this sin x, if you bring it to the left hand side, it comes to the denominator. This is cos x by sin x dx and minus e power y, and e power y plus 1, if you bring it to the right hand side, it becomes in the denominator, e power y plus 1. Already. See, this is the expression. So, our simple correction. Instead of sin x, I wrote sin y. That's the confusion. So now see, this is integral cos x by sin x is cot x, or you can integrate straight away. Integral cos x by sin x dx, derivative of the denominator is the numerator. Here also minus integral e power y by e power y plus 1 dy. E power y plus 1, derivative of this is e power y dy. Here also the derivative of the denominator d of e power y plus 1 is equal to e power y. Derivative of this is e power y, derivative of e power y is e power y, and derivative of 1 is 0, therefore the derivative differentiation of the denominator is the numerator. By definition, integral f of x by f dash of x by f of x. Formula is integral f dash of x by f of x dx. If the denominator function is derivative of the denominator function is in the numerator, then the integral value is log of the denominator. Log of f of x. That is our problem answer. This is a formula. So the denominator of the derivative should be in the numerator, then the integral value is log of the denominator. Therefore, the derivative of e power y plus 1 is in the numerator e power y dy. Therefore, this is minus log of the denominator e power y plus 1. Similarly, derivative of sin x is cos x in the numerator. This is also log of the denominator sin x. Since both the functions in log, you consider the constant is also a log constant, log c. So bring this log of sin x minus plus log of e power y plus 1 equal to log c. See, log m plus log n is log mn. So this is log of e power y plus 1 into sin x is equal to log c. So eliminating logarithm by giving exponential power on both sides, raising the power of exponentiation e power log of and e power log c become 1, therefore e power log is 1, therefore you will get eliminating e power log on both sides by exponentiation e power y plus 1 into sin x equal to c. That is the solution for this problem. This is general solution. Okay, that's all about the problem, and this rule is used here. Next problem. It is second one. This problem is the second problem. Next, third problem. In this video, I am going to solve third one. So, third problem, solve y dx minus x dy, y dx minus x dy into cot of x by y into cot of x by y equal to ny square dx. N into y square dx. This is the problem. Y dx minus x dy into cot of x by y equal to ny square dx. Find the general solution of this problem, or otherwise solve this differential equation. That's our problem. You see, y dx minus x dy into cot of x by y equal to, you bring this y square here. Left hand side becomes the denominator. You will get n dx only on the right hand side. You divide this y square in the left hand side. You will get, this is nothing but y dx minus x dy is nothing but d of x by y. This is d of x by y. D of x by y is y square into y into dx minus x into dy. Quotient rule. D of x by y is this. Y square, denominator y square, numerator y dx minus x dy. This is d of x by y. That this expression is this. Y square into x dy minus y dx minus x dy. Quotient rule. V square, v into du minus du into dv. Like that. So this becomes d of x by y. And already you have got x by y here. You will get n dx. Now integrating both sides. This is integral cot of x by y with respect to x by y. See, the problem is cot of x by y is d of x by y. So x by y is t, cot t dt. Like that. You suppose x by y you consider by t, cot t dt. Like that. This is integral constant n you can take outside n dx. So integral cot x dx, integral cot of x by y into d of x by y. That is integral cot x dx is log sin x equal to n into integral dx is x plus for constant c. Now raising e power on both sides, e power log of sin x equal to e power nx plus c. E power log is 1, so you will get sin x only. Sin x equal to e power nx plus c is e power nx into e power c. That e power c is again a constant c, e power nx. E power c is again a constant c, e power nx. Left hand side is sin x. That is the answer. This is the general solution for this problem. Because e power log is 1, so that it only sin x the left hand side equal to e power nx plus c. I can express as e power nx into e power c. So rule of index identity to you, algebraic identity is e power a plus b into e, so e power a into a, e power b like that. This is split into 2. E power c is again a constant c. Okay, one more problem I will solve. Let's solve about this problem also. These are the problems using the method variables separable. Next, fourth problem. Solve the differential equation tan y into dy by dx. Tan y into dy by dx equal to cos of x plus y plus cos of x minus y. This is the problem. Solve tan y into dy by dx equal to cot of x plus y plus cos of x plus y cos of x minus y. You know by trigonometric result cos a plus b plus cos a minus b is 2 cos a cos b. So there is a formula cos a plus b plus cos a minus b is 2 cos a cos b. A is x, b is y. Cos x plus y plus cos x minus y is 2 cos x cos y. By trigonometry result, you can write this expression into 2 cos x cos y. And here tan y dy by dx. Now, you bring this cos y to the left hand side, it comes to the denominator, that is 1 by cos y into tan y dy equal to 2 cos x dx. You know 1 by cos y is secant y. So this is integral 1 by cos y is secant y tan y. Secant y tan y dy equal to 2 in the integral cos x dx. Okay, integral secant x tan x is, integration of secant x tan x is secant x, you know. Integral secant y tan y is secant y by formula, integration formula. Integral secant x tan x is secant x. Similarly, 2 in the integral of cos x is sin x plus c. That's all. Secant y equal to 2 sin x plus c is the solution for this problem. That's all. This is called the general solution. If they are given the values of x and y and you substitute, you will get the unknown constant c, and then the value, if you replace the constant by another value, that is called a particular solution. But This is the general solution for this problem. That's all. So I will stop here. We will continue the remaining problems in the next video. Thank you.